In the last lesson, we learned the for loop, the perfect tool when you know exactly how many times you need to repeat an action. It's the counted loop. But let's look at two real-world programming scenarios. Password check. You need to keep asking the user for a password until the input matches the correct value. You don't know if it will take 1 try or 100 tries. Reading file. You need to keep reading lines of text from a file as long as you haven't reached the end of the file. You don't know the file's length. In these cases, you cannot use a for loop because you don't have a fixed count. You need a loop that continues as long as a condition remains true. Welcome to Lesson 3.05. Today, we are learning the while loop, the second fundamental looping mechanism. The while loop is the condition-controlled loop. It is the simplest and most direct way to express repetition. While this statement is true, keep doing this block of code. You might hear people say that anything you can do with a for loop, you can do with a while loop, and that's true. The difference is the readability and intent. First, the while loop syntax. The syntax for the while loop is deceptively simple compared to the for loop. It only requires a condition inside its parentheses. The syntax looks like this. However, to avoid an infinite loop, a trap we'll discuss soon, the three essential parts of any loop must still exist. They are just handled separately. Initialization. Done before the while loop starts. Condition. Done inside the while parentheses. Update. Done inside the loop's code block. Let's convert our classic 10-time counter into a while loop to see the structure. Initial check. The loop starts. Is I less than 10? 0 is less than 10? True. Iteration 1. Code runs. I is increment to 1. Next check. Is I less than 10? 1 is less than 10? True. This continues until final check. Is I less than 10? 10 is less than 10? False. The loop immediately terminates. Second, the danger, the infinite loop trap. The single biggest danger with the while loop is forgetting the update step. Part 3. If the condition is initially true and you don't put code inside the loop to make it eventually false, the loop will run forever until you forcefully stop your program. This is an infinite loop. The key to a safe while loop is ensuring that the code block guarantees that the condition will eventually become false. Third, real-world use. Sentinel-controlled loop. Password example. The while loop shines in situations where the loop is controlled by user actions or external factors, often called a sentinel-controlled loop. Let's look at the password check scenario. In this case, the condition is guess is not equal to secret underscore code. The update is scanf%d, ampersand guess inside the loop, which asks the user for a new guess. The loop keeps running until the new guess satisfies the condition. Fourth, for versus while choosing the right tool. For loop, when to use. When you know the exact number of iterations needed. Example, printing a grid of 10 by 10, iterating over an array of fixed size. While loop, when to use. When you loop as long as a condition is true, count is unknown. Example, waiting for user input, reading a file line by line, waiting for a server response. You now have a powerful, flexible tool in the while loop. It checks the condition before running the code block. But what if you have a scenario where you want to guarantee that the code block runs at least once, and then you check the condition to see if it should run again? This is perfect for things like menus, where you always want to display the menu at least once. Click on the next video to learn about the slight, but important variation. Lesson 3.06. Loops. Do while loop, the do this first, then check loop.